spent the last months working with family trees. For this, I gathered a lot of information directly from family members and collected everything in handwritten notes. When I collected more than 100 people, I realized that I want a proper way to visualize everyone. This is the topic I am dealing with in this video, a program that properly plots a family tree. In order to develop a program that can plot my family tree, I need to fulfill the following requirements. First, at least some data of the family that shall be visualized needs to be present. Second, I need a proper system to store family tree data in. The system will be used as the source for the plotter program. Next, the programming language Python shall be used. For generating the visual representation, the software GraphViz shall be used. This chapter will go over the requirements mentioned just now in sequence. Since the first and second requirement is to have some data available in a known format, I want to cover this first. I decided to use Excel for the first iteration, since it is easy to fill out without using any additional program except Excel. The Excel file is composed of two sheets. The first sheet contains the information about the individual people. The second sheet contains information about connections between people, like marriages or just being together. The fields of the first sheet are the following: the ID of the individual person, the first names of the person, the last name the person had at birth, the date of birth, the location of birth, the date of death, the location of death, the ID of the biological mother, the ID of the biological father, the IDs of the biological children, the gender at birth, and a flag whether the person is still alive. The last flag is useful for cases where it is known that a person has passed away, but the date is unknown. The fields of the second sheet are the following: the ID of bond, the ID of the first person, the ID of the second person, the date of the bond, and the location of the bond. Since this sheet is also used for bonds like girlfriend and boyfriend, or by just living together, some of these fields can be left blank. Generally, not all fields in both sheets just described are used in this version of the program, but are being left in for future changes. To have a set of data to work with in the program, the remaining task is to simply fill out the file. I collected some data from my family by drawing rough sketches of a family tree and collecting all relevant information in those sketches. Then I went through those drawings to fill out the sheets one by one. Generally, speaking to close relatives, especially the older members, can lead to quite the discoveries. In my case, I ended up with 257 individual people, so quite a lot. With the data now being available for usage, it first needs to be established what a family tree is composed of and how to create one. First of all, it needs to be clarified what shall be actually plotted. The goal is to plot a family in form of a family tree. A family tree is a structure composed of nodes and edges. Each edge represents a biological connection between nodes or people. The easiest family tree is composed of a single node. This means that this tree contains a single generation, represented by the single person. This tree can now be expanded in different means. The first step is to add the biological parents to this tree. These are added one hierarchy above the previous person to indicate their place in the family hierarchy. To indicate a connection by blood to their child, the parents are connected together with edges to form a connector node. This connector node is then connected with a child with another edge. Now, the family tree represents two generations that are related to each other. This tree can now be again expanded by different means. For example, the parents could have more than one child. If the number of children is uneven, one of the children is located directly under the connector node of the parents. If the number of children is even, the children are ordered under the parents so that the inner two children align with the parents. Another way to expand the tree is to add more members, for example spouses. Each of the children can have one or more connections to other people. These can also have children, repeating the before-mentioned structure. In principle, a family tree is a nested application of the parent-children dependency. There are also other edge cases, for example if one of the parents is not known. Then, a child only has one parent member. Finally, the inner workings of the program shown in this video shall be discussed next. The first step is to pass the data from the Excel file into memory. This is done with the library OpenPyXL. The data then needs to be restructured for easier parsing. This is done by creating a single list that contains each person as an entry. A single entry in this list, meaning for each person, is composed of 13 fields. These are identical to the fields in the Excel file. For children and spouses, the IDs are stored in a list instead of a string separated by a comma. With this data now being available, it shall be put into a nested form for easier parsing during plotting. This nested form is called cluster, and each entry is composed of 5 fields. The first field is the ID of the current person. The next field contains a list with a single entry for the biological mother. After that, a list with a single entry for the biological father is added. The next field is a list of all spouses. Finally, the last field is a list of all children. To add a new member to this cluster, a new cluster with the same structure is generated from the single entry for the person. The program uses an additional flag to know whether a person was already added to this structure. This is required to avoid infinitely nested clusters. If a person was already added to the cluster, the ID of the person is added instead of the new structure. The result is a nested cluster containing all people that share a connection. People without a connection were not yet tested. I expect that the program will just ignore them and not add them to the cluster. The generated cluster is now used in the next and most central step for this video, the plotting. The cluster needs to be somehow translated to a different form that another software component used for plotting understands. To generate the visual family tree, I used the software called GraphViz. The software is usually used to create diagrams like flowcharts. Since the structure of a family tree is somewhat close to a flowchart, I can use the software for this purpose. Luckily, GraphViz has a Python library that makes it simpler to interface with it from the established Python program. In this video, GraphViz will be used with its dot engine, and I will export the family tree as a PNG file. The first step when working with GraphViz is to create a tree object where nodes and edges can be added. The graph receives a general set of parameters that will apply to all new nodes, except specified otherwise in subtrees. These parameters define the overall shape of the graph, for example that edges between nodes are orthogonal, or that nodes are always a set distance away from each other. Next, the parameters of the nodes themselves are specified. For this version, the nodes shall be rectangular and filled with a solid color. The last set of parameters is to define the edges. Here, the width is specified and the arrowhead is set to none, because GraphViz will use arrows for edges by default. After creating the basic family tree object, every person needs to be added to it now. To add a single person to the tree, it is first checked whether the current person has any spouses. These are looped over and added, while also setting edges between the current person and the current spouse. Next, the potential children are added for the current person. After that, the parents of the current person are added, at least if they are available. This procedure is done recursively to get every person into the tree. To avoid infinite recursions, a new flag is introduced. This flag is only set if a person was added in the previous step. The recursion is achieved by applying the just explained procedure to the spouses, children, and parents. With the recursion finished, the tree shall be visualized and then saved to a file. The result is an image containing the visualized family tree. While the explaining part took quite some time, let me show you some examples on how the program works with different setups. The first setup is an average family with 2 generations, meaning that there are 2 parents and 2 children. This looks quite good, and if we change the number of children to 3, the plot still works out fine. The only slight issue might be that the lines on top are not centered on the children anymore. The second setup is the previous family, but expanded by several more people in different generations. As you can see, the program does manage to get most of the connections right, but starts to deteriorate for some specific configurations. For example here, where the lines start to go a bit crazy behind a person. The last setup is my own family tree, but anonymized. As you can see, this is very messy and tend to go a little crazy sometimes. A lot of lines are overlapping and have weird forms overall. Nonetheless, you still can somehow see a rough shape of a family tree. This result is by no means perfect or even usable, but for me it was a big achievement to have the program finally run through all people and to plot them all in one image. Now it's time to recap the covered topics and to show the next steps. In this video, a program was developed to parse an Excel file that contains data about a family tree. This program plots all involved people in one large image. The results are better for smaller bundles of people, but get messy and unusable for larger amounts of people. Especially the last points leads me to the next steps. I want to adjust my approach to the problem. Instead of plotting all people in a single large tree, I want to dynamically split the tree up into smaller chunks and plot each chunk individually. Next, I want to make it easier to see bloodlines in the tree. Currently, all edges have the same color. I want to make it possible to trace the different lineages by color. Another future development is to use the standardized .ged file format from other tools for family trees. This way, one could export the family tree in that tool and plot it with my program. Finally, I want to find a way to make the large plot more readable. The plot should not contain weird lines, and the individual parts should be spaced out a bit to leave more room. This should make reading the tree easier. I uploaded this video due to 2 reasons. I didn't upload for a while, and I want to share my current progress before I spend more months working on it. Generally, you can expect me to upload in a similar pace as this and the last video. I worked on several different topics that I won't share here on YouTube. Also, there's the usual difficulty of balancing a job, a relationship, friends, and this hobby. I actually started working on the next topic for GLaDOS during the start of June. I hope to get it done a bit more quickly to be able to share my progress here. Anyway, thanks for watching this video and see you in the next one.